Hey everybody, welcome to part 2 of our limits introduction video. We are getting into notation, how to read it, what everything means, and just a general discussion around it. And then the next video will be on 3 cases where a limit does not exist, unless this one goes quicker than I anticipate, and then I will put them at the end of this video. So let's go. All right, first thing, what is a limit? Well, here's the notation. How do we read this? So when you read this part, we read it the limit as, right? So maybe I should highlight with the highlighter and match it up. So when you read this is the limit as, then x approaches c, x approaches c, of f of x equals oh wait, I want blue again. How about equals L and L. There you go. So the limit as x approaches c of f of x equals, or is sometimes, is equals L. So yes, this can be is as well, and there we go. So this is how we read it. This of in front of f of x is not the multiplication of. Now, that's how we read it, and what does that mean? As the x value gets closer and closer to some number, and where is that coming from? Well, I'm glad you asked. As the x value gets closer and closer to some number c. So I just really tried to enhance the pink, okay? So the pink part is talking about that little arrow underneath the limit, that little subscript, right? From both sides. Now, over here, let's grab us some orange highlighter. From both sides. What am I talking about when I say from both sides? So here, this table, actually, it's a little messy. So I'm going to label this with the title, and this is going to read one-sided limits right over here. One-sided limits. Now that means we can look at a limit as coming from the left or from the right. So when we say from both sides, we actually mean one at a time, okay? We're going to do from the left, we're going to do from right, and that's going to be each side individually, right? So what else can we look at? So what else can we say? Trying to just do different colors so that I can really differentiate different things over here. I don't know what to do. So I'm going to use something that might not be the best of the highlighters. It might be a little dark, but so this one right here, okay, x arrow c has a little minus sign like in the exponent. Can you see that? And the one below, you see the little plus sign, right? Okay. So I just want to keep the whole thing on the screen for us. The way you read that is being from the left, not toward the left, but from the left. And on the other hand, right, you have, how about this one? This guy right here is from the right. So we're going to approach this x value. We're going to close in on it, okay? Troops coming in from the left side, from the right side. Okay, those are our one-sided limits. So all this, left side and right side. No, hey, that was rude. I guess I'll just outline it. You want to make a straight line? Then we'll make a straight line. We're going to go from the left side and from the right side, and that's what makes these each side, right? From both sides, the y value, this is important because what the limit is, in fact, is actually talking about the output or y value, okay? The y value gets closer and closer to some number L, the y value. So L is always a y value. C is always an x value. So the limit, the answer to the limit is L. The answer to the limit, okay, is L, and it's a Y value. Okay, I don't know where you have to write it. Y value is the L. Okay, C is obviously an X value. All right, so as X closes in on a certain value, I want to know where is my Y value closing in on. So if you ever use like almost like a tracker thing on a camera on a monitor, and you want it to follow a face, right? So it's basically figuring as you move left to right, it's going to move left to right, and then zoom or tilt up or down and get that Y coordinate as well, right? It's got to like calibrate in a sense. So we want to know, like, are we able to calibrate our left side and right side in agreement and going both towards a number? Now, it never said we reach that number. We get closer and closer. So again, that means don't need to reach it. We don't need to reach it. So think about, asymptotes. Think about holes in graphs. Like, could you be approaching something and not reach it? Of course. In that case, the limit will still exist. So here is just a more formal definition. If the value of a function, now that phrase, the value, it implies, the word value when you're talking about functions, most of the time you're talking about the Y value, the output value. If the value of a function becomes closer and closer to a unique number L, again, that's a numerical value of L. If it approaches infinity, is that a unique number? No. So infinity is a form of does not exist. Don't forget that. Tuck that in your brain. As X approaches a number C from both sides, the left and the right, the limit of the function as X approaches C is L. There you go. All right. So that notation, you want to color code it for yourself, for your own definitions. And a lot of this stuff, like when you're first doing it, it's going to seem intuitive. It's going to seem okay when you do it with somebody. And then you get an example by yourself and you're making a big old mess, right? So get this definition and refer, please just trust me, okay? Refer back to this definition every once in a while and make sure what your reasoning is and how your cognitive abilities come together to decide how to do a problem. Make sure they're still in agreement with this definition. If you start developing your own techniques and ways of getting your answers and you check in and they're not in agreement with this definition, it's like you're getting off track, right? You're veering off the path and you're doing something that might work some of the time, but it might not work all of the time. And that's what we want to watch out for. So this definition is explaining it. Now, I think I could do in a minute and so keep it under 10. I can go over the cases where a limit does not exist. So let's look at that. Cases when a limit does not exist. So a limit does not exist some of the time. And if you think about it, go back to the definition, think like, well, what has to be said, right? What is the logical argument that needs to be made that will make the limit definition not applicable, right? Read it again. It says, if the value of the function becomes close to a unique number L. Well, what if it doesn't become close to a unique number L? As we approach from both sides, well, what if it's different from each side? What if it doesn't even close in on a value? What if it doesn't go to a numerical value? These are really what the cases are, okay? So let's look at each of these. So this first case, As you approach, I'm going to try to leave the definition on the screen at the same time. Let's see what I could do for us. Yes. Okay. If the value of the function, so again, what are we talking about when we say value? We're talking about the y value, right? So the value is on the y-axis. The value of a function becomes close to a unique number L. Well, right away, I don't think that's the case. As x approaches a number c. Well, are we approaching a number c? As x approaches, we want to approach 2. And here's 2. As we approach a number c from both sides. So I'm going to approach from the left. What y value am I approaching from the left? From the left, the y value that I am approaching is, here, it's a -1. How about as I approach from the right side? Wait, what colors did I do for those? Blue for left, reddish from right. So let's be consistent, right? So keep the green back there. Sorry. So I'm looking at my y values. From the left, we did that bluish. So I'm coming from the left. What y value am I approaching? I'll write the answer right there. And then I did that, this one here. From the right, what y value am I approaching? I'll write the answer there. So what are the answers from the left? That would be -1. That's the y value, okay? Right there, I promise it's -1 in there. And then from the right, as I close in from the right, I get closer and closer to 2. Oh, I didn't write that down. 1. I lost that highlighter, right? Because we approached, oh no, it's there, 2 and 2, right? So am I approaching a unique number? No, I'm approaching 2 different numbers from each side. I'm approaching -1 from the left and then +1 from the right. They're not in agreement, right? I'm getting closer and closer to no unique number. So this is one case where a limit does not exist, okay? Next, what if I'm not approaching a number at all? No number, right? So if I'm not approaching a number, what does that look like? Okay, from the left, I'm getting closer and closer to a, oh, come on, guy. Trying to get, oh no, this guy with the auto straighten. I'm trying to get closer and closer to what number, you ask? As x approaches -1. Here's the -1. And what's over here in my way, like causing my graph to go absolutely crazy, right? Well, come on, thing. Get that out of my way. So from the left, I'm going up, 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 and away. What about from the right side? From the right, oh no. I'm sure you have me in double speed right now because this is going so slow right now. From the right, where am I going? So my left hand limit appears to be going where? My right hand limit appears to be going where? As a y value. Where's my y value going as x is getting closer and closer to the x value of -1. I'm trying to get closer to -1. I'm following the roller coaster track. And where am I going? Well, here my y value is approaching infinity. Here my y value is approaching -infinity. So not only are they not in agreement, they're not numbers. They're not numerical values. This limit does not exist. And frankly, even if this one was going up this branch instead of going down the way that one's going down, this is still going to infinity. I'm still not approaching numbers. The limit still doesn't exist. But in the case of this volcanic behavior, in that situation, if we ask for the limit, you're probably not going to write DNE. You're probably going to write infinity. But guess what? This is a form of does not exist. Okay, I promise it's under the does not exist umbrella. You know I like an umbrella. So that right there would still not exist. But in a nutshell, oops, sorry. In a nutshell, the definition is that I'm not even approaching a number. We're always breaking some part of the definition, and that's what makes it not exist. Next one. From the left, from the right, what's going on? Okay, I'm going to see if I can show you this one. I'm going over 10 minutes, right? Yeah, I'm at 14. Good job, me. Go, great, fantastic. From the left, what's happening is we are going up and down, up and down, up and down. You can't even see what I'm drawing right there because I'm tracing over myself. And from the right, as I approach 0, I'm going up and down, up and down, up and down, up and down. I'm trying to approach the value of 0. X approaches 0. So what is going on, right? Like, am I approaching a number? I can't see. I just see the little scribble scrabble. Well, I'm glad you asked. Let me pop something up. Okay, so here we are. I needed a second to just sort of get everything up on the screen. Here is an example. I'm going to save for another video a full explanation on how to use like table values to understand exactly why what's happening is happening here. But here you have y equals sine of 1 over x. So the reciprocal of an angle, okay? Sine of 1 over x. And if I zoom in on this, and I tried to explain this in class, but you know, we'll see how it goes. But I'm going to, on my iPad right now, zoom in on this by only zooming with like taking my graph right now, and I'm going to stretch it out horizontally so I could see better. So right now you see the boxes that are kind of marked up as like -1 and 1. So it looks like there's about 5 grid boxes per unit. So what is that? 0.2, 0.2, 0.2, right? So I want to zoom in and see like, well, can I see better what is going on? Oops. So let me see if I could do it again. Okay, do you see I'm pulling it apart? Perfect. Okay, well, all I see is it's still doing what I thought it was doing. Let's try it again. Okay, still doing it. Let's try. Let's try again. So this looks very tricky to do on Desmos. So you have to make sure you don't click on, like sometimes you could do it on your phone if you're lucky. There it is again. So I'm trying to zoom in and look where I am now, 0.05, right? Nope, don't click on that. Don't click on that. Nope, don't click on that. Gotta click on just the, nope, don't click on the graph. Don't click on the graph. See, you end up zooming in on all of it. Well, maybe. I don't know. Nope. Maybe it's not gonna let me do it. I don't want to zoom on the whole thing anymore. Well, I guess that's all I could do with my fingers right now, but I could always change the zoom if I wanted in the little wrench on the side. So if I drop out that wrench, I'm going to make my x-axis -0.01 and my y-axis 0.01. And okay, and let's like shift that over. Like this is where I'm at right now. Like I'm at 0.1 and it's just going forever. Okay, let's even... Can I click on here? Like I'm trying to click and get little points. Do you see where I am? I can't even tell where I'm clicking, right? I'm zoomed in. Can't tell. Nothing. It's just a big mess, okay? Big mess, big mess. So if I hit the home button, okay. So there I went back to the little original guy. So this little innocent, sweet looking little squiggle squoggle is a hot mess when you zoom in. It's just going up and down forever and never ever stops. Let's even see if I click on here, right? And you see me, okay, you can kind of see like what, obviously it doesn't even showcase what's happening, right? Does not even showcase it. Let's do back where I did zoom in a bit. Okay, let's try to trace one more time. So one more time as I come in, I'm trying, but it like really just jumps right on over that whole mess. Okay, so that is another case. Now, what is that called? This is called a situation where the graph will, let's see what color highlighter I could still use. Oscillating, okay, it's oscillating between two different values near C. So I can't really get to where I'm trying to go. I'm just going to zigzag back and forth forever and ever and ever. I will do a separate video because I find this one very interesting, the one I just did. It's not the exact one in the picture here, but it's a nice one to use. It's the same idea. It's probably, this is just like cosine of 1 over x, and I just did sine of 1 over x or something like that. But I think it would be a really great discussion. But again, I'm not closing in on a distinct value. There's no a jump discontinuity. It's just I can zoom in all I want, and the more I try to get there, the longer the journey becomes, right? It's like someone dangling a little treat in front of you and you think you're going to reach it and you're chasing after it and they just pull it further away, right? So you never ever get there. So I know this video went longer than I wanted, less than 20 minutes, but I think this is a very important concept, all of this. Oscillating, asymptote, jump discontinuity. Those are the cases where a limit does not exist. If you feel confident, happy, and like this was helpful, give a thumbs up. If you hate everything, go ahead, give it a thumbs down. I hope you're feeling happy though. Questions, comments, concerns, requests, and feedback can go in the comment section in the bottom part underneath. Check the description box and playlist to find more videos on this topic or a topic that might be beneficial to you. All right, that's it for now. Adios.